Oh, hi! I was just blowing the balloon. You know what? It's a new day, right? And we're gonna start a new chapter. So, I was just wondering why not start the chapter with an activity? And better still, why not start with an activity that can be performed by everyone at home? So, here I have the setup ready. If you see, I have vinegar. It is easily procured at anyone's kitchen. Again, I have baking soda. This again can be, found in the kitchen. I have an empty transparent bottle and a few balloons. So, are you excited to start the activity? Let's do it. So, without wasting much time, let's begin. Now, first what we do is we take an empty transparent bottle. Then, we take a little bit of vinegar and pour it inside the bottle. Make sure you don't pour too much. Now, what we do is we take a normal tablespoon and like this, we use the back of the spoon and take a little bit of baking soda and start putting it inside a balloon. One more. Now, let's see what happens. What I do is, I take this balloon and I take the mouth of the balloon and put it at the mouth of this particular bottle. You're following me, right? Now, let's see what happens. What I do is, see, this part of the balloon is actually containing baking soda right now. And I'm gonna take it like this and pour the baking soda. Are you seeing the magic? The balloon is blowing up by itself. So let's understand how this is happening. So what happened here is that the baking soda reacted with the vinegar and a gas was liberated, which is why you saw the balloon blowing up. Now, wasn't that interesting? I know it was. You can repeat the steps and impress your friends. Now, let me tell you that vinegar is an acid and baking soda is a base. This brings us to today's chapter, acids, bases and salts. Before we delve into the details of the chapter, let us first understand what these three substances are. Acids, bases and salts are three groups of chemical compounds which are useful to us in many different ways. First of all, let's talk about acids. All of us have tasted lemon, right? And we know that lemon tastes sour. Exactly. The sour taste of a lemon is there because of the presence of acid in it. And this particular acid is called citric acid. The chemical nature of such substances is known to be acidic. The word acid comes from the Latin word acere, which means sour. Even raw mangoes, raw grapes, lemon juice, orange juice, curd, vinegar and tamarind are all sour in taste because of the presence of acid in them. In fact, there is acid present in the bodies of plants as well as animals, and these acids are known as organic acids. Some of the important organic acids include acetic acid, lactic acid, tartaric acid, ascorbic acid, citric acid and even oxalic acid. Do you know acetic acid is found in vinegar, and there's another organic acid called formic acid which is found in the sting of ants. Now, can you tell me where citric acid would be found? In citrus fruits like lemons and oranges. Now, talking about tartaric acid, it is found in tamarind. Ascorbic acid is found in alma and oxalic acid is found in spinach. You know what? You'll be amazed to know that lactic acid is found in curd and sour milk. So we saw that organic acids are present in the food that we eat almost every day. Now this means that organic acids are weak in nature and are not harmful to eat or drink. Now there's another type of acid which is strong and harmful. It is known as mineral acid because it is formed by the minerals of the earth. Now these acids are not found in nature, they are actually man-made, and hence they are also known as man-made acids. We also call them laboratory acids because these acids are used in science laboratories to perform experiments. You know, there are three mineral acids which are most commonly used in science laboratories. They include hydrochloric acid, sulfuric acid, and nitric acid. Even mineral acids are used in our everyday lives. For example, we use hydrochloric acid to clean kitchen sinks as well as bathroom. And we use sulfuric acid in the making of storage batteries for cars, buses, trucks, and even inverters. One common use of nitric acid is at the goldsmith's shop because nitric acid is used in cleaning gold and silver ornaments. You know what? Concentrated mineral acids are very dangerous because they can burn the hands and even clothes. So they have to be used with utmost care. For this particular reason, in laboratories, concentrated mineral acids are diluted by adding water to it. Now, dilute mineral acids are far less harmful than concentrated mineral acids. Now, let's talk about the classification of acids. All acids can be classified into two types, strong acids and weak acids. The concentrated mineral acids are considered as strong acids like hydrochloric acid, sulfuric acid, and nitric acid. The weak acids include the organic acids. You know, there's one exception, the carbonic acid. Carbonic acid is a weak acid, but it is not an organic acid. Carbonic acid is used in fizzy soft drinks and soda water, which gives it a pleasant taste. So, the next time you are drinking them, watch out for carbonic acid. Champ, let me ask you a question. Have you ever heard about acid rain? You have, right? Well, can you tell me what is acid rain? Don't know. Actually, you will be surprised to know that the rain which contains higher level of acid than normal is called acid rain. Now you must be wondering, how can a rain contain acid? Actually, acid rain is formed when acidic gases such as sulfur dioxide, nitrogen dioxide, and carbon dioxide are released into the atmosphere by the burning of fuel. Now these gases mix with rain to form acids. For example, carbon dioxide mixes with rain to form carbonic acid. And when this acidic rain falls on the Earth's surface, we call it acid rain. Acid rain damages aquatic life, trees, plants, crops, and even stone monuments and buildings. Till now, we've been discussing about acids. Now, we are going to discuss a different category of chemical. Now, this category is called bases. As you can see over here, I have baking soda with me. Let me try and taste it. Yuck! It tastes so bitter. Do you know why it tastes so bitter? It is because of the presence of base in it. Now, let me try and put a little bit of water to this. Do you see? It has become soapy. Now, do you know why this happens? Because this is the nature of a base. It tastes bitter and it feels soapy to touch. The nature of such substances is known to be basic. Some common bases include sodium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, and also sodium carbonate. Now, bases are the chemical opposites of acids. Like we saw in this particular experiment, what happened is the baking soda, which is a base, neutralized the vinegar, which is acidic in nature, thus producing carbon dioxide, which filled up the space inside the balloon. You know, even bases are used in our everyday lives, like ammonium hydroxide is used in window cleaners. Sodium bicarbonate is used in washing soda, and sodium hydroxide and potassium hydroxide is used in the making of soaps. Now, coming to the classification of bases, it can be categorized into two types, strong bases and weak bases. Now, strong bases include sodium hydroxide and potassium hydroxide, whereas weak bases include sodium carbonate, magnesium hydroxide, and calcium hydroxide. Now, the strong bases are dangerous and they can burn our skin, but the weak bases like sodium hydrogen carbonate is actually used as an antacid to cure indigestion. It neutralizes the effect of excess acid present in our stomach. Now coming to the salts, they are chemical substances which are formed by the reaction of acids and bases. Now, apart from acids, bases and salts, there are certain substances which are neither acid nor base nor salt. They include water, glucose, cane sugar, etc. Now, I guess you are smart enough to know that we cannot taste all the substances to find out whether they are acid or base, right? Don't you think there must be some other easy way to find out the nature of a substance, whether it is acidic in nature or basic in nature, or whether it is a salt? Well, of course there is. Here we take a help of indicators. Now the question arises, what is an indicator? Now indicators are special type of substances which are used to find out whether a substance is acidic or basic. The indicators change their colors when added to a solution containing an acidic substance or a basic substance. So champ, by now we have got a basic idea of what are acids, bases and salts. In the upcoming video, we'll be performing a lot of fun activities by using different indicators to find out whether a substance is acidic or basic in nature. So watch this quick recap and catch me there. The sour taste of a lemon is there because of the presence of acid in it, and this particular acid is called citric acid. The chemical nature of such substances is known to be acidic. The word acid comes from the Latin word acere, which means sour. In fact, there is acid present in the bodies of plants as well as animals, and these acids are known as organic acids. Some of the important organic acids include acetic acid, lactic acid, tartaric acid, ascorbic acid, citric acid, and even oxalic acid. So we saw that organic acids are present in the food that we eat almost every day. Now this means that organic acids are weak in nature and are not harmful to eat or drink. Now there is another type of acid which is strong and harmful. It is known as mineral acid. Actually, acid rain is formed when acidic gases such as sulfur dioxide, nitrogen dioxide and carbon dioxide are released into the atmosphere by the burning of fuel. Now these gases mix with rain to form acids. Strong bases include sodium hydroxide and potassium hydroxide, whereas weak bases include sodium carbonate, magnesium hydroxide and calcium hydroxide.